Alright, as we look at example 3, I want to remind you that so far we've done a vertical parabola and a horizontal parabola. So if you feel pretty good with these straightforward basic examples, you're certainly welcome to potentially move on to other videos and use these merely as supplement. For those of you who want to hear example 3's explanation, I'll continue. So we have a y squared equals a negative 20x. So the first thing I want to remember is that we like the squared term to be on the right. So I could just immediately switch those sides. But I also want to remember that I want the coefficient not to be on the regular term, but I want it to be on the squared term. And so that means that at some point I'm going to have to get that coefficient on the right-hand side. Now sometimes students in this example have been known to divide y squared by negative 20, which is fine, but then I don't get to see it as a fraction, and I know that at some point I want to set that equal, so I really want to isolate it as, if it needs to be, a fraction as a coefficient. Alright, so go ahead and set up our mathematics off to the side, so we'll do 1 over 4p equal to our coefficient. You do not need to keep boxing the coefficient. I'm just trying to draw attention to where it's coming from. Now they're both fractions, so there's no need to use that division by 1 that you've seen in the previous two examples. We do need to potentially cross multiply, or you might even be able to look at it. If I wanted to figure out that the bottom is 20, I have a 4p, and the 1's already matched pretty much, then I think I need that to be a negative 5. So there's a lot of different ways to figure out what that value is. You want to be careful though, because here I can cite it and do well. Sometimes students back here will sometimes think that p should equal 2, and it definitely doesn't. So you want to make sure that you're taking your time and getting the correct value of p, but whatever way that you'd like to solve it is fine with Miss Olson. So again, we want to think about what's our standard form, so we've taken care of that. Since the y is squared, that's not our traditional one, right? We have this always to refer back to, the y equals x squared, that's normal, that's up and down. So we know that this will be left or right, so we are going to first name it as a horizontal parabola. I want to remind some of you that when you were naming things on the previous conics, you would often say ellipse, and you would forget to say horizontal or vertical. And I'm not going to continue to give you points for not being complete with the name. So we really need to focus in on that in this new and final conic. So we have a horizontal parabola. That means we have to decide if it opens left or right. When you see a negative, that sounds more like not the typical one, so we'll go to the left. Now, having set that up, we're going to once again have one more vertex at 0, 0. And the reason it's at 0, 0 is there's no shift on the x and no shift on the y. If it opens left, then I know the focus will be to the left and my directrix will be to the right. Like we discussed, when the equation is in standard form, if it starts with an x, we know that our directrix will start with an x as well. So we're going to use this p distance of 5, and it was kind of, with its negativeness, telling us that we were moving left. So that means my focus will change my x, again because it's a lead x, so it's horizontal, so everything important is happening to the x. And we'll go in the opposite direction. So if we go left 5, we go right 5. So 5 from 0 is 5. And we have everything we need for example 3.